All right, guys, so this is the last of our foldables for section 5.1, and this is just a bunch of theorems. And hopefully you've cut it out. You cut out along each of these bold dotted lines, and then you're going to fold over the dotted lines to where each of these here, here, and here become flaps, okay? And then when you open the flaps up, the top thing I have is on the left, and then this is on the right. I just had to coordinate it top and bottom rather than left or right to fit on this page, so hopefully that's not too confusing for you. Okay, now many would argue that the triangle sum theorem is the most important theorem in all of geometry. Okay, so I'm going to say that again. Some people think that this triangle sum theorem is the most important theorem in all of geometry. Now, guys, there's thousands of theorems in geometry, so for a lot to think this is the most important, that should tell you that this is kind of a big deal. Okay, and some of you may already know this, just not by name. The triangle sum theorem tells us that the sum of the measures of the, and I'm going to put here, interior angles in a triangle equals 180. Okay, so if we add up all the angles of a triangle, so here's angle B, here's angle A, and here's angle C, so I could say angle A plus angle B plus angle C has to equal 180 degrees, okay? Every single triangle, if you add up the three interior angles, it's going to equal 180 degrees. All right, so let's do an example. So if we look at this triangle, we know if we add the three angles, now we don't know G, it has to equal 180. So I can say 115 plus 35 plus angle G equals 180. Okay, now it's just algebra. So 115 plus 35 is 150 plus angle G equals 180. Minus 150, minus 150. So I get angle G has to equal 30 degrees. All right, so the second theorem we're going to talk about is the exterior angle theorem. Now this is the middle flap of the three. And once again, this is on the left-hand side, this is on the right-hand side. Now the exterior angle theorem is important because without this theorem, a lot of times problems are impossible to solve, so you really have to know this theorem. Okay, so this theorem tells us that the measure of an exterior angle of a triangle equals the sum of the non-adjacent interior angles. Okay, now let's read this here a minute. Non-adjacent means not next to. And then hopefully you know interiors inside. So if we look at this diagram here, the measure of the exterior angle, well, this is the exterior angle here, so I could say angle 1 is going to equal, it's going to equal the sum of the measures of the non-adjacent interiors. So the non-adjacent interiors, well, guys, this would be an interior, but this is adjacent. So the non-adjacent ones would be here and here. So it's the sum of those. So angle 1 would equal angle A plus angle B. All right, so let's look at this figure below in this example. So it says find the value of x. Okay, so the exterior angle, which is right here, so 2x plus 10, that's going to be equal to the two non-adjacent interiors. Well, non-adjacent, that means we can't do this one. So the other two angles would be x plus 65. Okay, now we've taken a geometry problem and turned it into an algebra problem. So let's subtract x on both sides. So I get x plus 10 is equal to 65. Minus 10 on both sides, I get x equals 55, and that is my answer. Okay, so there's a couple other helpful theorems or helpful hints that this talks about. So the first one, remember this is on the left-hand side right here. and this is on the right-hand side down here. So it says if two angles of one triangle are congruent, and I'm just going to put the sign, to two angles of another triangle, then the third angles are congruent. Okay, now this is also called the third angles theorem. And we will actually discuss this in a little bit more depth, or in a lot more depth, in the next section. Each angle of an equilateral triangle has a measure of, we already did this, an equilateral triangle is equiangular. So it's 60 degrees. If all three sides are the same, then all three angles are the same, which means each of them are 60 degrees. In a triangle, there can be at most one obtuse angle or right angle. Can't be more than one obtuse and can't be more than one right in a triangle. All right, the last one, it says the acute angles of a right triangle. So you have a right angle and then two acute angles. They are complementary. Okay, now let's look at this example. All right, it says find the measures of the acute angles of a right triangle ABC if angle A is x minus 6 and angle B is 2x. All right, well, we have a bunch of words and we don't have a picture, so we're going to draw a picture. So we have a right triangle. It doesn't have to be to scale. And it says we want to find the measures of the acute angles, and then it gives us angle A and angle B, so we're going to assume angle C is the right angle. And then A and B are the acute angles, so I'm just going to say A and B. And I know that angle A is x minus 6, and then angle B is 2x. All right, so if I go back and I look at each of these that I just did, which of them talks about the acute angles of a right triangle? Well, look, acute angles of a right triangle are complementary. So I'm going to use this one right here. Okay, so the two acute angles of a triangle are complementary, which means that x minus 6 and 2x are complementary. Okay, now, what does it mean to be complementary? We'll go back to chapter 1. To be complementary, that means they add up to 90 degrees. Okay, so plus 6 on both sides, we get x plus 2x is 3x. Those cancel out, equals 96. So x then must equal 32. Okay, but notice it doesn't tell us to solve for x. It says find the measures of the acute angles. Okay, so x minus 6 is this angle, so 32 is x. So this one has to be 26 degrees. And then here we have 2 times 32, which is 64 degrees. So here's the measure of my two angles here.